So what we're going to do here is we're going to test a hypothesis. And I'm going to go through and set how we can test the hypothesis. And there's two ways we do this. One is we generate a p-value, which is a probability value. And it's the probability of our hypothesis, our type 1 errors, and how wrong we are. And so it's a way of testing the probability of our assumptions. The other one is using rejection regions. They both are actually doing the same thing. What happens is p-values give you a number, and that number you can use to compare to alpha. So if p is less than or equal to alpha, you reject the null hypothesis. And if p is greater than alpha, you fail to reject the null. And so here's what this looks like, and this is going to be helpful for us. If I'm doing a right-tailed test, the p-value measures whatever my test statistic is, be it a z-score or a t-score. It measures the probability to the right of it. If I'm doing a left-tailed test, the p-value, whatever my test statistic is, be it a z-score or a t-score, etc., it measures the probability in there. And if I'm doing a two-tailed test, well, that and that, whatever the probability is by my test statistic, right, my critical values and my negative critical values, all right, I take whatever the area is here and I multiply it by 2. So the probability of ZC times 2 gives me my test statistic there. And that will lead us over into what are called rejection regions. And how this links us to the rejection regions is interesting, is these areas, if our Z value or T value falls into this area, then we reject the null. So the other thing we can do is we could take this critical value of Z, and if it's a right-tailed test, if our test value of Z is greater or equal to that critical value, we reject. If it's a left-tailed test, if it's less than or equal to the critical value, we reject. And if it's a two-tailed test, if what we have to do is we have to look. And so a two-tailed test I'll show a little bit more clearly here. All right, let's say this was Z critical of 3, which means that the other side would be negative 3. Then if our Z score was 2, we fall in here and we fail to reject. And so these are the two tests that we do when we go about testing hypothesis. We'd either do a p-value or a rejection region. And so what I'm going to do here is I'm going to do an example, and I'm going to do it both ways. So let's do this example here. Let me bring it up here. So in auto racing, a pit stop is where a racing vehicle stops for new tires, right? And so there's an efficiency, and we can make a claim that the time it takes for tires and fuel is 13 seconds. So we take a random 32 stops, and we get a mean of 12.9 seconds. So assuming that the population standard deviation is 0.19, right, we've done enough sports statistics, what they call sabermetrics in this, that we have an idea of what the standard deviation is across the sport. Is there enough evidence to support the claim at 0.01 alpha? The significance level is 0.01. And we're going to use both a p-value and a critical value and the rejection regions. We're going to show it both ways. And so the thing to look at is the claim is less than 13 seconds. Alpha is 0.01, n is 32, right? So here we go. Let's put this all together. here. All right, so we're looking at the significance level of 0.01, and the claim is, so we'll state our claim, and I'm going to say that it's going to be an alternative hypothesis, and it's saying that the mean is less than 13 seconds. So that's what we mean by when we set up a hypothesis test, and I'll even label this as being the claim. Then the null hypothesis is the complement of that. And so that's everything else. We're saying that the mean is greater than or equal to 13 to be the null hypothesis. And so this is the claim. And so the first thing we're going to do is we're going to calculate our test statistic. So what they did is they went through and they did 32 tests, and they found that the average of those samples was 12.9 seconds. Seconds in here. And so what we need to do is we need to use this test statistic to check on our claim. And so what we're doing is, will we reject the null hypothesis, or will we fail to reject the null hypothesis? Now, what was the other portion of this was, we know that the standard deviation is 0.19 seconds. And so we know the population standard deviation is 0.19 seconds. And so since the population standard deviation is known, the test statistic we're going to use is a z-score. If you think back to confidence intervals, we used z-scores when we knew the population standard deviation to get a confidence interval, and we used the t-scores when we didn't. Same thing's going to happen with hypothesis testing. So we're going to have, for our test value, sure we're seeing everything as we should. Yep. All right. X bar minus mu over the standard deviation divided by the square root of n. Or 12.9 seconds divided by 13 seconds over 0.19 seconds divided by the square root of 32. And depending on how you want to calculate this, you can go to your calculator. You can do a couple of different ways of looking at it. And so I'm going to hear me type on the calculator here. Oh. And what did I get here? I got roughly negative 2.98 on my z-score. Negative 2.98. And so that's my z-score. So I want to make a drawing to get an idea of what I'm looking for. I note that this is pointing left. And so I'm over here. I'm in negative 2.98. So it'd be nice to know what this line is. And so this line, or the probability in here. So let's start with the probability that the probability of a z of 2.98. And so we can go to the tables, or we can look it up using Excel. And so we'll start with calculating the z-score in Excel. So switching over to our spreadsheet here. Now, let me get the right value showing up. 2 seconds here. Let's see if that works now. Whoops. Equal, I've got it showing over here, but it is not updating on the screen here. This happens sometimes. Let me fix this. I'm just going to switch it to this one, and then switch it back. There we go. And so what we want to do is we want to we want to find a z-score, and we want to find the probability that goes with it. So we're going to use the normal distribution, normal.dist, and then in the number we got, negative 2.93, comma, our mean is 0, and our standard deviation is 1, that's the normal, and then it's going to be true for cumulative. And what was I? 2.93, 2.98. I apologize. I saw 2.98. And so there is our p-value. So we use the normal distribution, the z-score we got, 0, 1, 1, and there's our p-value hanging right out. And so we'll write down the p-value here. And so what this is saying is this is the probability of us getting a type 1 error. And so now we can compare the p-value to alpha, and we'll see that the p-value is less than alpha. So the p is less than or equal to alpha, that's true, which means we reject the null hypothesis. And by rejecting the null hypothesis, we're down into the claim. And so what we say is there is enough evidence to support the claim. Now, completely another way of doing this involves taking alpha and turning it into a critical value of z. And so if we come back here, the other way we can do that is we can use our inverse normal, and our alpha was 0.01, and our mean is 0, and our standard deviation is 1, and we get a critical value of negative 2.33. So notice normal inverse, if we put in alpha, you get a critical value. And so what that means, so if I come back over here, is my critical value is at negative 2.33. And so if I plot where my actual test statistic was, so this line that defines the rejection region is at negative 2.33. Well, my test statistic was negative 2.98, which is in here, and it falls within the rejection region. So I reject the null hypothesis. And so these are two ways of doing the same thing. One is find the p-value and compare it to alpha. The other is to use alpha to determine your critical value. And then you compare your test statistic to alpha, or to the critical value. Sorry. P-values you compare to alpha, test statistics you compare to rejection regions. They both do the same thing. I'm a rejection region person. You'll probably see when the question doesn't ask you to use it one way or another, this is what I go. But again, loads of the literature for especially biological and medical sciences use p-values. So calculating the p-value, take your test statistic and look this up in the normal table. And that's how we test statistics and hypothesis claims. And then when we state, right, since we rejected the null, we say there is enough evidence to support the claim. Notice we're not talking about the truth. We're talking about the quality of our data versus the statement we want to make.